Good morning, everyone. Today we'll be learning biomechanics part 4, a brief introduction of biomechanics. This is not the entire biomechanics. So let us learn about muscle contraction and relaxation phenomenon. See, whenever we think that yes, muscles contract and relax and they transfer the force to the bones to move. No, bones are very much hard like steel. So when the muscle is contracting and relaxing, the forces don't transfer to the bone, bones don't move. Bones form a hinge joint. Example, consider an example. Bones form a joint, a type of hinge joint, which move, which tend to move by the force of muscle. Bones don't move. Thus, joint moves. Okay. Whenever we talk about movement or muscle contraction, there are two types of muscle: agonist and antagonist. Agonist performs the desired action, performs the desired action. Antagonist is exactly opposite to the agonist, that is, resist the desired action. For example, when you're eating food, you just need to bend the elbow, but also you need to straighten the elbow in order to grab the food from the plate. So, thus, straightening the elbow grabs the food from the plate, flexing or bending the elbow puts the food in the mouth. Again, you need to straighten, again, you need to bend. So, thus, the agonist and antagonist are in reverse action. When agonist contracts, antagonist has to relax naturally. This is a natural phenomenon. Nobody is telling antagonist, excuse me, please, you need to relax so that I contract. No. When agonist is contracting, antagonist has to relax, and vice versa. You can see in the video when blue one is contracting, red one is relaxing. And red one is relaxing, blue one is contracting, which is vice versa. Pure vice versa. Now, also remember when agonist contracts, antagonist relaxes. This needs to occur or needs to happen mandatorily when a human body is working. Now, why? Why when agonist is contracting, antagonist cannot contract? You can see in the video, agonist and antagonist, not only by action they are opposite, by the placement they are opposite. So when you're eating your food, your elbow needs to bend. When you want to take a food from plate, your elbow needs to straighten. Now, if your brain is telling both agonist and antagonist to contract, you'll never reach the plate or your food will never reach the mouth. The person will be confused whether to bend the elbow or to straighten the elbow. So thus, our God has nicely designed the human body that agonist and antagonist are working efficiently in an opposite manner. When brain wants to eat food, when your elbow is bending forward, that means when your elbow is flexing, the opposite muscle has to relax. And when your elbow is straightening, the opposite muscle has to relax. Talking about the muscle contraction, there are three types of muscle contraction. Basically, there are two types. The first one is isotonic and the second one is isometric. Let us understand the second one because it is very easy to understand. Iso means same. Metric is nothing but meter. Meter is the measurement of length. So isometric means same length. Isotonic, the word tone, same tension. The word metric, same length. Tonic, same tension. Okay. Whenever throughout the contraction, the tone remains same. The tone remains same is known as isotonic. Whenever throughout contraction, the length remains same is known as isometric. So if the same thing is tonic and metric, what should be different? In isotonic, there is variation of the length, and isometric, there is variation of the tension of the muscle. The diagrammatic representation is this thing: concentric, isometric, eccentric. Isotonic has two types: concentric and eccentric. Okay. A concentric meaning shortening. This one. Isometric is no change in the length. Eccentric is this one. How do you draw and understand it? Now, if consider this is your joint, normal joint. This is the angle. Say about X angle. When this X angle becomes very small, that is X, the angle of this is smaller than smaller than x, that means it is concentric. When the angle becomes equivalent to x, that means it is isometric. When the angle becomes more greater than x, it means eccentric. Okay, so concentric and eccentric are two different types of isotonic, and isometric is there is no change in the length, that is angle becomes equivalent to x. Thank you so much for today's lecture. Next lecture is very interesting. Please be attentive in the YouTube screens. Thank you.